Hey guys, tonight we begin with a question that has rested at the edge of human thought for as long as we've looked up at the night sky. What existed before the Big Bang? Welcome. Tonight we'll move gently through a series of stories, ideas, and quiet reflections about beginnings. Not to hurry you, but to invite you into a calm, thoughtful journey. We'll touch on the nature of time, the limits of our science, ancient and modern ways of imagining origins, and some of the most beautiful, strange theories physicists and philosophers have offered. We will wander through wonder and reason, through poetry and math, and by the end you'll have explored many possible answers, and perhaps come to appreciate the question itself in a more peaceful way. Before we settle in and begin our peaceful journey, take a moment to like this video and subscribe, only if what I share here truly resonates with you. Your support helps me create more of these videos, and if you feel like it, let me know where you're tuning in from and what time it is. It's always fascinating to see the many corners of the world where we connect. Now, dim the lights, make yourself comfortable, and let's ease into tonight's journey together as we explore what lies ahead. Chapter 1. The question that time forgot. There is a gentle ache that comes with certain questions, not an urgent, sharp ache, but a low, steady one that draws the mind outward like the tide. What existed before the Big Bang sits among those questions, a soft, persistent call that asks us to step beyond the familiar edge of time and peer into silence. Begin by imagining a quiet shore at midnight. The sea is vast and the sky hangs heavy with stars like distant lanterns. You stand at the water's edge and notice the first glimmer of light on the horizon. You ask the ocean, with the smallness of a single human voice, where did this water come from? The ocean answers only with its breath. The world has felt this way about origins for centuries. The universe, like that ocean, seems both immediately present and mysteriously deep. This question, what came before, is irresistible for a few reasons. First, it asks us to move beyond the world we know into a domain where words become fragile and images blur. Second, it calls on the most patient parts of our minds, imagination, memory, and the slow work of inference. And third, it speaks to something personal. When we ask where the universe came from, we're also asking where we came from and why there is something rather than nothing. The question folds outward into cosmology and inward into the human heart. Scientists, philosophers, poets, and dreamers has all been drawn to this question. It is easy to picture an ancient thinker, seated beneath an open sky, tracing constellations with a finger and wondering whether the sky had a first stitch. In quieter moments, we too look up and feel a kinship with those long-ago reflections. The modern language may invoke equations and radiation, but the feeling that underlies all of it is the same. A desire to make sense of origins, to hold a narrative that can cradle our curiosity. Why does this question haunt us so persistently? Part of the answer lies in how we experience time. From childhood we learn to order events, first, then, later. Our lives are stitched together by memories and expectations. Time is the loom on which our stories are woven. To ask what came before the beginning is to ask about the loom itself, its maker, its rhythm, its possibility of starting or never starting at all. That is unnerving and at the same time deeply fascinating. But there's another layer, one that often goes unnoticed. The question tells us more about ourselves than it does about the cosmos. When we ask before, we bring to the cosmos our category of sequence, our preference for causes, our comfort with chains of events. We assume beginnings behave like doors in a hallway. One opens, another closes. Yet the universe may not be obliged to follow our habitual metaphors. The very structure of how we pose the question maps human experience onto cosmic reality. Observing that mapping gives us insight into the human mind. its hunger for stories, its search for continuity, and its willingness to hold paradox beside wonder. Let me offer a small story to soften this idea, a short, imagined encounter that may help the question sit more gently. There was once an old watchmaker who lived on the edge of a small town. He had a reputation for fixing things that seemed beyond repair, clocks that had stopped decades before, music boxes that no longer remembered their songs. One winter evening, a young teacher came to him with a watch that had no hands, a watch that the teacher described as the beginning itself. The teacher wanted to know if the watch could be made to tick from nothing. The watchmaker took the watch, smiled, and opened it. Inside there were not gears in the way the teacher expected, but a soft, empty space where gears might be. For a long time he simply held the watch, feeling the warmth of it in his palm. Then, with steady fingers, he placed a tiny mirror where a gear should have been and closed the case. Now, he said, the watch reflects the light it finds. It does not tell time in the way you asked, but it offers a way to notice time when it arrives. The teacher walked away thinking, perhaps beginnings are like reflections. Perhaps asking what came before is less about finding a starting mechanism and more about noticing how presence and absence play together. The watch did not answer the teacher's original question, but it shifted the way the teacher watched the sky that night. She found that sometimes the important work is not extracting the origin from the mystery, but learning to sit with the mystery in a way that changes how you live. That story is not science, and it does not resolve cosmology. What it does suggest, gently, is that our questions can change us, and that there is value in learning to hold a question without rush. In this documentary, we will do just that. We will let questions open outward slowly and listen to the quiet spaces around them. We will follow evidence where it leads and welcome imagination where evidence cannot yet tread. Tonight's exploration will balance curiosity with calm. We'll examine what cosmologists mean by the Big Bang, not as loud explosion, but as the description of an expanding universe. We'll learn how looking at the universe is in many ways looking back in time, and why our observations can tell us only so much about the earliest moments. We'll meet the singularity, the place where our equations stop making sense, and we will sit gently with the idea that the laws we cherish might be emergent rather than absolute. Later we'll visit speculative ideas that stretch the mind. Quantum origins, where nothing is more like a restless potential. Universes born in bubbles of inflation. The notion of a cyclical cosmos that breathes in and out, and even haunting proposals that suggest our cosmos is a projection of deeper information. We will also trace the echoes of these modern theories in ancient stories of endless cycles and timeless being, and ponder what it means that people across cultures have long imagined beginnings beyond beginnings, but for now, remain here with the question as an invitation rather than a demand. Notice your breath as you listen. Let the image of the shore at midnight return if you like, or imagine standing at the base of a mountain watching clouds move slowly across its face. There is a peculiar comfort to admitting ignorance in good company. You're not expected to fill the silence, you're invited to be present to it. Before we move on in the coming chapters, I'll leave you with a small, soothing thought. Sometimes the deepest truths arrive not as answers but as perspectives that make our ordinary lives feel larger and softer. Whether the cosmos had a literal before, or whether time loops and rebounds, or whether beginnings are a property of something deeper we have yet to understand, each possibility carries with it a new way to stand beneath the night and feel our connection to the vastness. When you're ready, rest a little deeper into your seat. Allow the question to rest beside you. Like a companion at the edge of a floodlit path, gentle and watchful. In the next chapter, we will gently unfold what scientists mean by the Big Bang itself, how that phrase came to be, and what evidence supports our picture of cosmic birth. We will explore how the universe unfolded from early heat and light to the calm of galaxies and stars. But for now, breathe and let the quiet be enough. Chapter 2: The Birth of Everything. Close your eyes for a moment and imagine a small, bright seed of light. Hold that light gently in your mind. Now picture that seed slowly, steadily, becoming larger and larger, not because it was thrown into empty space, but because the space around it itself was growing. This is the simplest way to hold the idea of the Big Bang, not a bomb going off inside a room, but space itself expanding, carrying everything with it. Long before there were stars, planets, or the soft hush of night, the universe was unimaginably hot and dense. If you could stand there, if there had a meaning, you would feel a heat so complete that particles and light could not separate. It was all mixed together. Energy, tiny bits of matter, and light that bounced constantly between them. As the universe expanded, it cooled. That cooling was gentle and steady, like a kettle slowly losing its steam. As the heat dropped, different kinds of order began to appear. Think of the early universe as a kitchen where a recipe slowly becomes a meal. First came the basic ingredients, tiny particles that would later make up atoms. A few minutes after the very first instant, the universe had cooled enough for protons and neutrons to join into simple nuclei, mostly hydrogen and helium. For a long time after that, the universe was a bright, glowing fog because electrons and nuclei could not settle together. Light could not travel freely without bumping into charged particles. Then, about 380,000 years later, an almost unthinkable span of time from the point of the first fractions of a second, the universe cooled enough for electrons to join nuclei and form neutral atoms. When this happened, light could travel much more easily. The universe became transparent, and the first faint afterglow of that time spread out in all directions. That afterglow is still with us today as a cold, soft whisper of light, stretched into the dark by the long expansion. We call that whisper the cosmic background radiation. It is the echo of the early, hot state of the universe, now cooled to a temperature far below the cold of deep space. The fact that we can measure this faint glow is one of the strongest reasons scientists believe the universe began in a hot, dense state, and then expanded. Another piece of the picture comes from the way distant galaxies appear to us. When we look at the light from most galaxies, we find it shifted toward the red, stretched like the sound of a passing train, because the space between us and them has grown while the light travelled. This stretching tells us that, on average, the universe is getting bigger, and that distant galaxies are moving away from us. Taken together, the afterglow and the redshift, the evidence paints a consistent story of expansion from an earlier, hotter state. A common image used to explain expansion is a balloon with dots on its surface. Pretend the dots are galaxies and blow up the balloon. Every dot moves away from each other not because the dots are crawling across the surface, but because the balloon itself is growing. This helps to show why the Big Bang is not an explosion at a single point in space. Rather, every point in space was once much closer together. Space itself is the thing that stretches. Within the first sliver of a second after the beginning, something remarkable may have happened. An enormous, lightning-fast stretching of space called inflation. Imagine a tiny patch of fabric being pulled so quickly that tiny wrinkles were smoothed out and tiny differences were stretched far apart. Inflation would have taken a region no larger than a grain of sand and stretched it far beyond our view. If inflation happened, it helps explain why the universe looks so smooth on large scales. with only small variations that later became seeds for galaxies and clusters. As the universe continued to cool over millions and then hundreds of millions of years, those small differences in density grew under the pull of gravity. Some regions became a little denser, gathered more matter, and eventually collapsed into the first stars. Those first stars were different from our sun, huge, bright, and short-lived. They cooked the light elements into heavier ones and seeded the space around them with the ingredients for planets and life. Over billions of years, galaxies formed, collided, and danced into the large structures we see today. Vast webs and filaments of galaxies separated by darker voids, like islands in a deep sea. It is important to stress what the Big Bang Theory actually names and what it does not. The theory describes the early hot, dense state and the expansion that followed. It explains how matter, light, and large-scale structure evolved, and it makes predictions that match what we observe. But it does not by itself tell us why the whole thing started, or whether there was a moment before the hot state that led to it. That part is where physics meets its limits, and where ideas become more speculative. Even so, the story of the universe from the hot early state to the cool star-filled cosmos is rich and deep. It is a story of transformation, of heat becoming light, of random motion giving way to structure, of simple atoms assembling into complex chemistry. Each stage contains its own quiet beauty. Picture for a moment the first light that finally travelled freely through space. Imagine that light stretching for 13 billion years until some of it arrives at a tiny telescope on a mountainside. That light is a time messenger, carrying a memory of when the universe was newborn. There is a softness to this history if we let it wash over us slowly. Each stage can be held like a scene in a long, slow film. The first hot soup of particles, the settling into atoms, the birth of the first stars, the slow march towards structures large and small. Each step is a gentle unfolding, not a sudden leap, and noticing that helps us feel calm as we consider the grand scale of time. As we continue, it helps to remember two simple facts. First, the Big Bang is a name for the early hot, dense phase of an expanding universe, and second, the physical traces we can measure, background light, stretched wavelengths, and the large-scale web of galaxies, are the anchors that make this story more than dream. They are evidence that lets scientists piece together the past like careful listeners, interpreting a long, faint song. In the coming chapters, we'll see why looking backward has its limits, why telescopes are time machines, and why there is a horizon beyond which we cannot see. We will explore the strange place where our equations break down, called the singularity, and we will gentle our way into questions of time itself. We will ask whether before has meaning in the way we expect, and we will meet ideas that suggest the universe could have started in many surprising ways. So settle deeper now. Let the image of the early, warm light become a soft, glowing memory behind your eyelids. Feel the calm of knowing that this vast story is gently held by patterns we can measure and by questions we can still ask. Later, we will turn toward the edge of observation and consider how the light that tells this tale also hides other chapters we have not yet read. For now, breathe slowly and allow the quiet geometry of expansion to make space in your mind. Chapter 3. The Edge of the Observable. Imagine standing on a quiet beach at night with a lantern in your hand. Each step you take toward the water brings a new part of the shore into view, but no matter how far you walk, the ocean still stretches beyond the lantern's light. Telescopes are like that lantern. They bring more of the universe into view, but there is always a distant edge where the light grows too faint, or where the universe itself keeps secrets. When we use a telescope, we're doing something very gentle and strangely powerful. We're looking back in time. Light travels at a fixed speed. It takes time for light to cross the vast spaces between stars and galaxies. So when we look at a star that is 10 light years away, we see it as it was 10 years ago. When we look at a galaxy a billion light years away, we see it as it was a billion years ago. Each distance is a step back through the history of the cosmos. Telescopes are time machines in the calm sense. They let us read the old pages of the universe's story. This means the farther we look, the earlier in time we see. If we could somehow look far enough away, we would see the universe as it was near its birth. But a gentle truth stands between us and the very earliest moments. The universe was once full of a dense, hot fog that did not let ordinary light travel freely. For the first hundreds of thousands of years, charged particles and light were locked in a bright, churning dance. Light bounced from particle to particle and could not travel straight for long. That haze hides the very first chapter from ordinary sight. Around 380,000 years after the hot beginning, the universe cooled enough for charged particles and electrons to join and form neutral atoms. When that happened, light could finally travel much farther without constant bumping. The first free light went on a long journey, and after 13 billion years, some of it reaches us as the faint glow we call the cosmic background radiation. That glow paints the sky like a soft, very cold wallpaper, and it is the oldest light we can see with ordinary telescopes. In a way, it acts like a calm, distant shore we can reach with our lantern. Beyond that shore lies a place we cannot see with light alone. Because of this, there is what scientists call an observable horizon. It is the largest region from which light has had time to reach us since the beginning. Anything beyond that horizon is simply too far for its light to have arrived yet. Think of being in a misty field at dawn. The places you can see are set by how far the morning light has spread. Even if the field continues forever beyond the fog keeps it hidden. You might ask, what if we had perfect telescopes, the best mirrors, and the deepest patience? Could we not just look a little more and see what was before the first light? The short, calm answer is that ordinary light cannot carry information from a time when the universe was opaque. That does not mean there are no other possible messengers, but each kind of messenger meets its own limit. Some particles, like neutrinos, interacted only lightly with the early fog, and could, in principle, bring us clues from earlier times. Gravitational waves, tiny ripples in space, could also carry a memory from the very first moments. Detecting those signals is a huge technical challenge, but the possibility is real. Still, even these messengers might only take us to a point. The ultimate origin could be veiled by deeper limits. There is another subtle limit set by the size of the region that could have ever affected us since the beginning. This is called the particle horizon. It is the distance light could have travelled since the start of the universe. Inside that region, events could have had time to influence us. Outside it, they could not. The particle horizon is not a fixed wall in space, but a moving boundary that grows as light has more time to travel. It's a gentle reminder that cause and effect in the universe are tied to how fast signals can move. We should also think about how the universe's expansion itself shapes what we can see. As space stretches, light travelling through it also stretches, shifting toward longer, redder wavelengths. This stretching can make faint signals from far away even harder to see. In addition, if the expansion of the universe speeds up, parts of space can slip away from us faster than light can travel between them because the space itself is growing. That creates regions that will forever remain out of reach, even in the far future. Even when we imagine having infinite technology, there remain deep reasons why some things may be forever hidden. If time itself, at least as we understand it, began with a hot, dense phase, then asking what came earlier may be like asking what is north of the North Pole. Our usual ideas of earlier and later rely on time's steady march. If that march started at the Big Bang in the sense that time itself has roots there, then there is no earlier moment to look for by any signal or machine. This is not a failure of skill or cleverness. It is a difference in the way reality is arranged. Still, scientists are creative. Where ordinary light fails, they search for other traces. The cosmic background radiation contains faint patterns, tiny hot and cold spots that tell us about how matter was spread in the early universe. These patterns are like fingerprints left at the scene of a slow, ancient event. By measuring them with care, researchers learn about the density of matter, the role of dark matter, and hints about processes that occurred even earlier, like inflation. Inflation, if it happened, would have left subtle marks that might be read if we listen closely to these patterns, or if we detect the right kind of gravitational waves. It is a quiet archaeological work. Sift the faint signals, look for shapes, follow the whispers of the past. The idea that other methods, such as gravitational waves or neutrino backgrounds, might open a tiny window past the cosmic fog gives us hope without rushing us. These channels are like different kinds of lanterns. Some can pass through fog that blocks ordinary light. But even so, the reach of any lantern is limited by deeper, structural boundaries set by space and time. There is a poetic side to these limits. They remind us that our view of the universe is both vast and narrow. Vast because the amount we can see and learn fills us with a kind of small, steady wonder. Narrow because there will always be edges, places where the map ends and mystery begins. Those edges are not failures, they're invitations to imagine, to create, and to reflect. As you listen, picture the universe like a long ocean voyage that we travel by starlight. Each star is a shore we pass, and each shore shows us a moment of the journey. Some shores are near and clear, others are far and faint. Some are hidden behind mists that only certain kinds of light can pass. This voyage is calm. We are not rushed. We can enjoy the feeling of learning to read time as if it were a slow, gentle map. In the coming chapter, we'll step closer to the place where our usual rules, the neat equations that describe gravity and motion, no longer behave the way they do. That place is often called the singularity, a word that suggests a breakdown, a moment where our maps falter. We'll approach that idea slowly and with softness, exploring what it means for physics to meet a boundary it cannot explain. For now, rest in the quiet knowledge that the cosmos gives us real clues to its past, and that some parts of its story may forever remain like a faint melody heard from a far shore. Chapter 4. The Mystery of the Singularity. There is a quiet place in the story of the universe where our best maps stop making sense. We call that place the singularity. The name sounds sharp and final, but the feeling it gives is softer. It is not a thing we can touch so much as a sign that our old ideas are asking for help. Imagine a peaceful path through a garden that slowly narrows until the trail disappears into mist. The trail does not vanish because the garden ends. It vanishes because the path we were walking on can no longer be used. The singularity is like that misty ending for our rules about space and time. To understand why the singularity matters, it helps to remember how we normally describe the world. For many things, planets, stars, the motion of objects, we can use simple rules. These rules are very good at predicting how things move and how gravity pulls. They tell us that massive objects bend the space around them, like heavy stones resting on a stretched sheet. Small marbles roll toward the stones because the sheet slopes. These ideas help us predict orbits, tides, and the path of light near a star. For most of life, these rules work gently and reliably. But when we follow those rules backward toward the start, they begin to behave strangely. If we let the bending of space get more and more extreme, our math starts to show values that grow without limit. Distances and densities and the bending of space seem to blow up to infinite numbers. When our formulas say infinite, it is a steady signal that the model is being asked to describe something it was not built to handle. It is a calm, clear signpost. We must step back and rethink the tools we're using. The singularity shows up in a very particular way. It is not that space suddenly becomes a dot or a tiny ball. Rather, the mathematics that describe space and time give no smooth answer at that spot. Like a map that suddenly has a torn edge, the equations that usually guide us cannot tell us what happens there. They do not describe a scene so much as they admit. We do not know. This is why the singularity is less a place and more a limit. It tells us where our current picture of reality needs a new language. There are two simple ways to think about what is going wrong. The first is that our idea of smooth space and time breaks down when densities and energies become extreme. The second is that the rules we have, good rules for many things, ignore very small-scale effects that become important at extreme conditions. In everyday life, ignoring those small effects is fine. In the very early universe, it is not. It is like trying to build a house with only a hammer, when what you really need is a whole toolkit. At the singularity, the toolkit we bring is missing a key instrument. Scientists have developed deep ideas to show that this breakdown is not just a fluke in one equation, but a real sign that something fundamental is missing. The work shows that under wide and simple conditions, if matter is pulled together by gravity in certain ways, a breakdown will happen. This gives the singularity its weight as an honest problem to solve, not a trick of math. The universe seems to point with a calm finger to the limit of our knowledge. What might replace the old rules where they fail? Many researchers think that at the tiniest scales, far tinier than atoms, space and time themselves might not be smooth. Instead, they may be grainy, or made of discrete bits, or described by a different kind of logic. If space and time have a deeper structure, then what looked like a breakdown might only be a sign that we were looking at something with the wrong lens. Imagine looking at a digital screen up close. The image seems to break into pixels. From far away, it is smooth. The singularity may be our close-up view of a region where the smooth view no longer holds. To make this idea gentler, let me tell a small story. Once, a young potter worked at a wheel on a cool morning. She wanted to make a perfect bowl. At first, the clay answered her hand smoothly. She shaped, pushed, and watched the curve form. But when she pressed too hard at the center, a crack began. The tools she had could not fix that crack. A different approach was needed. The potter paused, let the bowl rest, and returned with a new plan. A thinner touch, a different clay, a change in temperature. The crack taught her about limitations and new methods. In the same way, the singularity tells physicists that new plan is needed, a different way of thinking that can handle the crack without fear. One important idea that often arises is that we may need a theory that blends gravity with the rules of the very small, the world of atoms and quantum things. Right now, gravity and quantum ideas succeed in their own realms, but they speak in different tongues. Bringing them together calmly is like teaching two friends a new language so they can chat. If a true union is found, the singularity might be smoothed away, or it may be replaced by a gentler beginning where our old infinities no longer appear. Another peaceful thought is that the singularity might not be a single moment at all. It could be a sign that time, as we usually imagine it, changes character. Perhaps before the hot, dense phase, time did not march along in the way a clock measures. Maybe time was more like a field or a pattern that only later took on the familiar form we now experience. If time itself is a kind of emergent property, something that grows out of deeper rules, then asking what came before may be the wrong question, or at least a question that needs new words. It is also worth noting that not all singularities are the same. Some are gentle. They can be removed by changing our point of view, or by choosing different coordinates, much like looking at the same scene from another angle. Other singularities are more stubborn. They persist no matter how we view them. The one connected to the earliest moments of the universe is of the stubborn kind in our current theories. That stubbornness is what pushes researchers forward with curiosity rather than discouragement. Even in the face of this admitted ignorance, there is a calm joy in the work. The very fact that our equations point clearly to their own limits is a kind of invitation. It tells us where to look for new laws, not where to give up. The singularity is a signpost toward deeper knowledge. It is a place where imagination and careful math meet, and where gentle persistence may produce a new, clearer language. As we reflect, feel the edges of your own questions. Notice how it feels to be told that a map is incomplete. There is room here for wonder, for the possibility that the universe is richer than our current stories. This gentle not knowing can be a peaceful thing. It frees us from the need to have final answers now and lets us rest in the patient work of discovery. Coming up, we will move from the idea of a breakdown in our rules to a deeper reflection on time itself. We will ask whether time might be something that was born along with the universe, rather than a stage that existed beforehand. We will explore what it might mean for time to emerge from a more basic reality, and how that shifts our sense of cause and effect. For now, breathe slowly and let the image of the potter's bowl sit with you, a reminder that cracks teach us new ways to shape what comes next. Chapter 5. When time itself was born. Take a slow breath and imagine a calm river. The water moves in one direction. It carries leaves, it carries light, and it shapes the banks as it goes. For most of us, time feels like that river, a steady flow from past to future, carrying moments one after another. We mark that flow with clocks, memories, and plans. But what if the river itself had a beginning? What if the current of time started only after the first page of the universe was turned? Tonight we will explore softly and simply what it might mean for time itself to be born. First, notice how we treat time in everyday life. We say before and after, as if events line up on a string. We think of causes and effects. One thing leads to another. Clocks and calendars give time shape. This way of seeing time works perfectly for most things. It helps us build houses, remember birthdays, and watch the dawn. But when we try to put time under a microscope and follow it back toward the very first moments, our usual pictures begin to wobble. One important idea is that time might not be a basic feature of reality. It might be something that appears when certain conditions are met, like frost forming on a window when it gets cold enough. In that case, time would be an emergent property, which means it shows up from deeper rules but is not a step-by-step part of the underlying system. If time emerges, then asking what came before time may be like asking what colour is north of the North Pole. The question changes meaning. To feel this more clearly, imagine a stage with actors. When the curtain lifts, the actors begin a scene. The story has a clear before and after inside the play. But behind the stage, in the wings, the props and ropes exist without the scene's order. The backstage may have its own rules that do not read like the play. Time, from this view, is like the order of the play, a feature that makes sense for the actors on stage but not for the tools and ropes behind the curtains. Scientists have ways to think about this idea without losing calm. One gentle way is to notice that some descriptions of the universe treat time as a useful label, rather than a fundamental thing. In those descriptions, you can imagine the universe as a whole pattern, where what we call time is only a way of reading changes in that pattern. The pattern exists, but the flow we feel is a perspective inside it. There is also a quiet, practical reason to consider time as something that can be born. Many laws of physics use time as a parameter. They tell how things change as a variable called t moves. But in the extremes near the beginning, those equations either break or no longer follow the smooth behavior we expect. If time is part of the way things change, and that way of changing falls apart, then it is possible that the smooth, steady t we use is not available before the hot, dense phase. In plain words, the clock we use may have only started ticking once certain conditions were met. Another helpful image is a winter garden. During winter, most plants are dormant. There is life beneath the soil, but it is not visible in the same way as in spring. When spring arrives, buds open and the garden seems to start growing, but the life was always there in some form. Likewise, time might be more visible to us after the universe cooled and certain structures formed. Before that, whatever existed might not have contained the ordered sequence we call time. We also feel the pull of reason when we ask whether a before is even meaningful. In ordinary cause and effect thinking, causes are earlier than effects. But if the rules that set up cause and effect depend on the existence of time, then cause and effect cannot be used to speak of what happens before time started. The very idea of earlier and later may lose its teeth. This can be unsettling, yet there is a calm dignity to simply accepting that our language and intuition are not always fit for every part of reality. Let us pause for a soft story that may make this clearer. Once, an old librarian arranged books in a great circular room. The books were not as we know them. Each one contained a whole world of events, and each world had its own sense of order. Some books told stories from left to right. Others pictured events that could be read in many directions. A curious visitor asked the librarian, "Which book came first?" The librarian smiled and said, "Some books begin where you expect. Some do not have beginnings in the way your hands expect. The question of first only makes sense in books that are written for your kind." The visitor, smiling now, sat down and learned to read each book on its own terms. That simple tale helps us remember to match our questions to the object we study. If time is like a book that opens in the middle, asking what is before the opening page may be a category mistake. The right move is to learn the grammar of the book to understand how it tells its tale. For cosmology, this means building new grammar, new mathematical and conceptual tools, so we can speak about the deep ways reality might be arranged. There are also graceful ways to keep before in conversation without losing clarity. For example, we can say that the universe had different phases, one where our usual time works well, and one where it does not. We can ask about transitions. How did the familiar flow of time emerge from a prior state? Transitions are gentle topics because they invite exploration of change rather than a search for a single origin point. They let us ask about how order forms from a prior pattern that may not be time-ordered. One thread that often appears in these conversations is the arrow of time, the reason time seems to flow in one direction. In daily life, we remember the past and not the future. We age forward, and broken things rarely assemble themselves back into order. Part of this feeling is tied to how disorder or spread grows in many systems. When a hot cup cools, it does not spontaneously heat up. When a building collapses, we must work to rebuild. This simple idea gives time a direction. If, at very early times, conditions were set so that disorder was very low, then the growth of disorder could set the arrow of time. In quiet ways, the arrow is less a metaphysical god and more a bookkeeping record of how systems arrange themselves. If the low disorder start itself is a condition that appears at the emergence of time, then the arrow and time are linked. That means asking what happened earlier is asking why the record started where it did. But again, if that question uses the language of time itself, it might be asking a shape that does not fit the thing we seek. There is a calm beauty to all this confusion. It asks us to be humble and slow. It asks us to treat questions like careful visitors, not loud intruders. And it opens the possibility that the universe is kinder and stranger than our first images. We are left with a soothing thought. The birth of time, if it happened, is not an abrupt command that says life is pointless. Instead, it is a gentle unfolding that made the world hospitable for change, memory, and meaning. As we move forward in this documentary, we will meet ideas that try to make these thoughts concrete. Some suggest that quantum rules make time fuzzy at the smallest scales. Some propose that time is one of many possible orders that the deeper reality allows. Some even suggest that there is no fundamental time at all, only relations between things that give a sense of before and after. Each idea is a map that covers parts of the territory. We will explore them one by one, slowly, with calm curiosity. For now, let the idea of time as a born thing soften in your mind. Imagine the river of moments starting at a hidden spring, whose source is not a single point but a quiet place where many small factors came together. Rest in the sense that not knowing a final answer is not a failure. It is an opening. When you are ready, breathe slowly and feel the gentle order of your own rhythm, your heartbeat, your breathing, the quiet shift from one thought to another. These are signs that time, as you live it, is here and kind. In the next chapter, we'll turn to one of the boldest ways to think about origins, the quantum origin idea, where nothing might be not empty but full of possibility. We will follow that thread with care and gentleness. Chapter 6. The Quantum Origin Hypothesis. Take a slow breath and imagine a still pond at dawn. The surface is smooth, like glass. For a long while, nothing seems to move. Then, without a loud sound or reason, you can see a tiny bubble forms and pops. It was not there a moment before, and now it is gone. In the world of the very small, reality behaves a little like that pond. Quiet does not always mean empty. Tiny, brief events can appear and vanish. That is the gentle start of the idea we call the quantum origin hypothesis. At the heart of this idea is a simple, surprising fact. Empty space is not truly empty. Even when there is no light and no matter, empty space hums with possibility. In the language of physics, we say the vacuum is alive with fields. These fields can wiggle a little, even when everything seems calm. Those wiggles are called quantum fluctuations. They are small, quick changes that rise and fall like tiny ripples on the pond. Most of the time they're so small that they leave no trace. But sometimes, under the right conditions, those small wiggles can grow into something bigger. One way to think about it is to picture a field like a wide, soft sheet stretched across the sky. In most places, the sheet is flat, but along the sheet there are tiny dimples and bumps that come and go. If a bump grows large enough, it might become a new patch of space that behaves differently from its neighbours. That new patch could expand and become a universe of its own. In this picture, nothing is more like a quiet sea full of tiny, restless waves. From that restless sea, a full universe can, in principle, bubble up. A second idea that sits beside this one is that energy can borrow itself briefly from the vacuum. This sounds odd at first, but in the world of the small, strict rules can be more flexible for short times. That allows tiny particle pairs to appear, dance, and then vanish back into nothing. These are often called virtual particles. They leave no lasting trace most of the time, but if the conditions are right, the borrowed energy can be turned into something real and lasting. The universe could begin from such a rare, lucky fluctuation. Several thinkers have built models that use these basic ideas to explain how a whole universe might begin from a kind of quantum nothing. One calm and beautiful version of this idea imagines that space and time can be smoothed out into a rounded shape, like the surface of a sphere. If you live on the surface of a sphere, you can go anywhere without meeting an edge. In some versions of the quantum view, the universe closes in on itself at the earliest times in such a way that there is no sharp boundary or before. The story then says the universe came from a rounded state where time behaved like another direction of space, and so there was no painful edge to the timeline. This is sometimes called a no-boundary idea. It is like imagining the pond surface curling gently, so there is no shoreline to step over. The history is complete and smooth. Another gentle idea related to the quantum picture uses the image of tunneling. In everyday life, a ball sitting in a small hollow in a hill will stay there unless someone pushes it over the rim. But in the quantum world, the ball can sometimes slip through the hill as if the hill were transparent for a moment. That process is called tunneling. Applied to the whole universe, the story says that the universe might have started when the quiet background tunneled into a state that expanded. The universe did not need a hand to push it. It simply found a path through a kind of barrier that blocks classical changes. From our view, that moment looks like spontaneous creation. All of these ideas, bubbles from vacuum, no boundary smoothing, quantum tunneling, share a soft common theme. What seems like nothing may still have rules and patterns that make creation possible. The word nothing here is tricky. For everyday use, nothing means an empty box, no objects and no light. But in the quantum view, nothing can mean a simple state of the fields, not a complete absence of structure. That state can be restless and ready to blossom into something. It is important to be clear and calm about what these ideas offer and what they do not. They give a possible path from a quiet quantum world to a living, expanding universe. They make the idea of spontaneous creation sensible in a way that follows known physical ideas, adjusted to the smallest scales. But they are not proven beyond doubt. The math is clever and promising, and some predictions may be tested by looking for subtle patterns left in the oldest light, or by seeking specific types of ripples in space itself. But much still hangs on whether the universe truly behaves the way these models suppose. A soft story might help the feeling of these ideas. Imagine a dark room with a single gentle heater. For a long time the room is cold and still. Then a tiny ember glows, and from that tiny ember a slow fire grows. No one started it in a way you can point to. The conditions were just right. A bit of dryness, a breath of warm air, a small spark. The fire is not mysterious in the way of magic. It is a natural outcome of the setup. The quantum origin idea is like that ember and fire. The conditions of the vacuum might be enough to allow a spark that grows into a whole universe. This picture also connects to why the universe looks so smooth on large scales, and yet has small irregularities. Quantum fluctuations are random and small, but when the universe expands, those small differences can be stretched into seeds. These seeds later grow into stars and galaxies, tiny wrinkles turned into great structures. In that way, the quiet randomness of the quantum world becomes the rich variety of our cosmos. As we listen, hold the word possible gently. Quantum ideas open a calm window to how creation might happen without the need for something outside the universe to act. They suggest that the rules of nature themselves carry the capacity to begin. That thought can feel both simple and vast. Simple because the cause is part of the thing that is created. vast because it implies a deep kind of self-sufficiency in nature. Before we move on, let me give a quiet tease for the next chapter. We will explore the grand idea called eternal inflation and the multiverse, how inflationary growth could create many bubble universes, perhaps with different properties. It is a bold, gentle thought that can make our universe feel like one house in a vast, calm neighborhood. Stay with me. The story grows in scope without losing its quiet center. Breathe slowly now. Imagine the pond again, and picture a single, gentle bubble lifting from its surface and then becoming a wide, bright world. Let that image rest beside you as you settle deeper into calm. Chapter 7: Eternal Inflation and the Multiverse. Take a deep breath and picture a quiet field of wildflowers at dawn. One small flower opens, and then another. Before long, patches of colour spread across the field. Now imagine that instead of flowers, patches of space appear and grow, each becoming its own world with its own skies and stories. This is the gentle image behind the idea of eternal inflation and the multiverse. Long ago, when scientists first thought of inflation, they imagined a very brief, fierce stretching of space that smoothed the universe and set up the seeds for stars and galaxies. But some versions of this idea show that inflation may not have been a one-time event. Instead, inflation could be a process that keeps going in some places, while pockets of space stop inflating and settle down into calmer regions like ours. Those pockets would be like bubbles forming in a slowly boiling pot. Each bubble could cool, form particles, and begin its own history. In that way, our universe might be one bubble among many. The word multiverse sounds grand. It can make the mind spool out into a vast view of countless worlds. Yet the basic steps of the idea are simple and quiet. Start with a kind of field that drives inflation. Most of the time, that field keeps things in an inflating state, but in some places the field can shift and inflation ends there. Those places become islands of calm, where particles appear and galaxies may form. Inflation continues elsewhere, so new islands keep forming. The process may be eternal in one sense. There's always more inflating space that can make more islands. The result is a gentle, endless production of bubble universes. Each bubble could have different traits. The laws and constants that shape physics might vary from bubble to bubble. In one bubble, the strength of forces might be weak. In another, it might be strong. In some bubbles, stars and life like ours may be possible. In others, the conditions may be so odd that whatever forms there would be radically different from what we know. The thought is not meant to make us feel small in a sad way, but to open a soft doorway to wonder. If many kinds of bubbles can form, the one we live in is a place where the conditions allowed stars, planets, chemistry, and life to come about. That alone invites a quiet kind of gratitude. A calm worry sometimes rises in people's minds when they hear about the multiverse. They ask, if there are many universes, does that make ours less special? The gentle response is that even if many bubbles exist, each bubble is unique in its own way. Knowing there might be others does not erase the beauty of this one. Imagine a forest with many trees. The existence of other trees does not make this tree less alive or less worth noticing. It simply widens the view. Another careful thought about the multiverse is how we might learn if it is real. By its nature, much of the multiverse would lie beyond the reach of our observations. The bubbles may be so far apart that we can never travel between them or see direct signs of another bubble. Yet the idea is not without hope. Some versions of inflation predict tiny traces in the patterns of light we see in the oldest glow of the universe, or faint ripples in the fabric of space that might one day be detected. If such subtle signs matched what inflationary theory predicts, they could be gentle hints that the wider process is real. In calm terms, Science looks for fingerprints. Even when the whole hand cannot be seen, a print on a surface can tell us a story. There is also a quiet philosophical side. If many universes exist with different properties, then some deep questions we ask, like why the physical constants have the values they do, might be answered by selection. In a vast ensemble of bubbles, only some will have the right conditions for life. So it is not surprising that we find ourselves in a bubble that supports life. If we were in a bubble that did not, we would not be here to ask the question. This line of thought is called an anthropic view. It can feel strange at first, but in gentle reflection it becomes a modest, practical idea. It does not claim that everything is explained, but it offers a frame for understanding how chance and selection may shape the conditions we observe. To bring this idea closer to home, imagine a long row of doors in a quiet corridor. Each door opens into a room painted a different colour. You walk through one door and find blue walls. You wonder why your room is blue and not red. If someone told you that all rooms in the corridor exist and each has its own colour, the blue room would be one among many. That knowledge does not make the blue room less interesting. It simply tells you there is a wider house beyond the door you entered. Some versions of the multiverse are more radical. They suggest that the number of possible universes is vast, even infinite, and that every way things could be arranged might actually happen somewhere. That idea can be dizzying. But we can keep our feet on the ground by remembering that infinite is a mathematical idea, not an emotional one. For our purposes tonight, the point is quieter. Inflation offers a simple mechanism that could produce many regions with different properties. Whether the number is large or small, the gentle picture is of a calm, generative process. There are also worries that the multiverse idea might be impossible to test and therefore not scientific. That is a fair concern. Science prefers ideas that can be checked, even in clever or indirect ways. Proponents of the multiverse respond by showing how some versions make specific, testable predictions about the one bubble we inhabit. If those predictions fail, we should rethink the models. If they succeed, the models gain support. Patience and careful measurement are the scientists' slow, steady tools. Let me offer a short story to soften the imagination. Once, a clockmaker made clocks that chimed in different tones. Each clock was wound slightly differently and told the same hour in its own voice. Visitors loved to listen as the clocks chimed together, each sound adding a colour to the room. A child asked the clockmaker why he made so many clocks. The clockmaker smiled and said, "Because each clock shows time in its own way." Listening to many clocks teaches us how many ways time can be made to sound. In a similar gentle way, the multiverse asks us to listen to many possible ways the world could be arranged. Our own little universe is one voice in a grand chorus. As you rest with these thoughts, notice the calm possibility that our cosmos might be only a part of a larger ensemble. That thought can free us from the hunger for a single, absolute answer. It allows room for surprise, for multiple beginnings, and for gentle humility. In the next chapter we will consider another graceful view, the cyclic universe, where the cosmos breathes in and out, expanding and contracting in a slow, endless rhythm. We will meet ideas that suggest beginning and ending can be part of a steady beat. Breathe slowly now and imagine the field of bubbles settling like dew at dawn, each one softly lit, each one quietly different. Let the idea rest beside you like a distant lantern. Chapter 8. The Cyclic Universe. Take a gentle breath and imagine the slow rise and fall of the sea. The tide comes in, touches the shore, and then retreats. There is rhythm there, a calm repeat that can feel like a steady heartbeat. The idea of a cyclic universe borrows that quiet rhythm and asks, what if the cosmos itself breathes in and out? What if beginnings are not one-time events, but part of a long, gentle cycle of death and rebirth. The cyclic picture is simple to hold in the mind. Instead of a single start followed by forever expansion, the universe might go through long phases. It could expand, slow, and then contract back, only to expand again. Each full cycle could last far longer than a single human life, billions or trillions or more of years. To live inside such a cosmos would be to sit in a very long, slow rhythm where each beat is a whole history. Stars form, galaxies live and fade. Then the cosmos winds down and prepares for the next breath. One of the reasons people find this idea comforting is that it removes the need for a single, absolute origin. If the universe cycles, then the question, what came before, gets a calm answer. Another cycle, perhaps similar, perhaps different. But the picture is not only poetic, it also faces deep puzzles. A central issue in cyclic models is the problem of memory. As the universe goes through each cycle, what carries forward? Do structures and information survive a contraction and bounce, or does each cycle wipe the slate clean? To think about this, we use a slow image of writing on wet sand. The tide rolls out and erases every word. If every cycle erased the information of the last, then the history would feel new each time. But some versions of cyclic ideas allow soft traces to pass between cycles. The mathematics behind these models can be arranged so that certain patterns or laws survive the bounce, like a faint echo that nudges the next cycle into similar shapes. That possibility leaves room for a kind of continuity without demanding exact repetition. Another important idea is how the universe avoids a destructive crash during the collapse. If the cosmos contracts without limit, densities and energies might blow up and ordinary physics would break down. To have a smooth bounce, the physics at very high density must change. Some thinkers suggest that new forces or quantum effects act like a cushion, stopping the collapse and turning it into expansion again. Others imagine that collision with another higher dimensional object, if such things exist, could trigger a fresh expansion. The key is that the bounce must be gentle enough to allow a new cycle to begin rather than a final singular end. A calm worry we can hold is the question of entropy. Entropy is a word scientists use to describe disorder. In everyday life, we notice that disorder tends to grow. A tidy room tends to get messy unless someone cleans it. If disorder always rises, then each cycle should be messier than the one before, and the universe could not repeat cycles forever in the same way. To make cycles work, some models propose a kind of cleansing step, a way for the universe to reset low disorder before the next expansion. That reset could happen through processes that smooth or dilute the messy parts during contraction or bounce. The details are technical, but the gentle image is clear. Nature needs a way to tidy up a little before starting again. There is also the human meaning in cycles. Many cultures imagine time as circular rather than linear. Seasons return, lives follow rhythms, and myths tell of ages that come and go. The cyclic universe resonates with these older ideas. It ties the deep science to our lived sense of rhythm and return. That connection can make the view feel more intimate, as if the cosmos is not a single dramatic birth, but a long, patient melody with repeating themes. Let me offer a small story to hold this thought softly. Once, in a quiet village, an old bell was tolled each morning and each evening. Children grew up with the bell's voice. Some learned to read by its rhythm, others learned to tell stories by the time it marked. One night the bell cracked and fell silent. The villagers were sad, but a new bell was cast and hung in the same tower. Its tone was slightly different, but the village found that rhythm again. They realized the bell had not been the village's life. It had merely given shape to time. time. The cyclic universe is like that bell. Cycles shape a larger story without needing a single first ring to define everything. Cyclic ideas also change how we think about beginnings and ends. If cycles are possible, then beginning becomes a local word, referring to the start of this cycle's history rather than the absolute start of all reality. That softens the pressure to find one first cause. It also opens a new kind of wonder. If cycles can carry variation, then evolution on a cosmic scale becomes possible. Universes could drift in character across cycles, exploring new rules and new patterns in a very slow, patient way. Another gentle feature of some cyclic models is that they can match observations we make today. They can be built so that this cycle includes a phase that looks very much like the Hot Big Bang, followed by inflation and galaxy formation. In that sense, a cyclic view can be more like a frame that holds many familiar pages. It does not reject evidence. It weaves evidence into a longer rhythm. As with other ideas we have met, there are parts of the cyclic view that remain speculative. We do not yet have a clear, fully tested mechanism that shows how a smooth bounce works in detail and how entropy is handled across cycles. But the idea serves as a powerful thought shape. It helps us imagine time as a form with breath, not a single arrow. It invites patience in the sense that endings may be doors to new beginnings. Before we move on to the next chapter, which will explore mirror universe ideas, where time might run backward, or where matter and antimatter suggest a twin cosmos, let the image of the sea's rhythm rest with you. Imagine the world expanding like the tide, then gathering itself, then stretching outward again. Feel the quiet comfort that comes from thinking in cycles, change without catastrophe, return without repetition, and a long, slow music that carries many stories. Breathe in slowly now, and match your breath to that slow cosmic rhythm. Inhale as the universe expands in our imagining. Exhale as it contracts. Notice how calm the pattern is, even when it reaches great scales of time. This calm is not ignorance, it is a gentle acceptance of possibilities. Chapter 9. The Mirror Universe Theories. Take a slow breath and imagine standing in a quiet room with a large clear mirror. You lift your hand and the figure in the glass lifts its hand too, but in a way that looks reversed. The mirror shows a world similar to yours but flipped. The idea of a mirror universe asks a gentle, curious question. What if there is a universe that is like ours, but in some deep way runs the other way, or is made mostly of the opposite kind of stuff? There are a few ways to hold this idea without getting tangled. One simple idea is about matter and antimatter. For every kind of particle we know, electrons, protons, and so on, there is a matching partner called an antiparticle. Antiparticles are like mirror images. They have the same mass but opposite charge. When a particle meets its antiparticle, they can meet and vanish in a flash of energy. Long ago, when the universe was hot, particles and antiparticles appeared in great numbers. If the balance had stayed perfect, all of that matter and antimatter would have met and disappeared, leaving only light. But here we are, in a universe filled with matter. That means somewhere along the way a slight imbalance favoured matter over antimatter. This small tilt is one of the soft, deep puzzles in cosmology. Some mirror universe ideas use that puzzle as a hint. They ask, might there be a mirror region where antimatter dominates instead of matter? In that mirror region, the roles would be reversed. What we call matter would be rare and what we call antimatter common. If such a region existed far away, it might be mostly hidden from us. The idea is gentle. It does not demand strange new rules, only that parts of the full reality made different choices when they cooled and formed into particles. Another morning-like way to think about mirror universes uses time itself. Imagine taking a short film of a raindrop and playing it backward. The backward film looks odd. Ripples move into the drop, puddles pull up into the cloud, and broken cups assemble themselves. A mirror universe running backward in time would look to us like that reversed film. Events that we see as cause and effect would look inverted. Some scientists have explored models where our universe has a twin that begins when ours ends, but with the arrow of time reversed. In that twin, the past and future swap places from our view. This sounds strange, but it is a playful way of asking whether time's direction might not be the same everywhere. A calm aspect of these ideas is that they try to answer deep puzzles in simple ways. The dominance of matter in our region could be paired with an antimatter dominance in a mirror region, so that overall balance is restored in the big picture. The arrow of time, why time seems to move one way here, might be balanced by an opposite arrow in a twin region. The whole arrangement could be symmetric, like a gentle mirror placed across the middle of a long room. It's important to keep the tone measured. These mirror ideas are clever and peaceful, but they are not proven. They are ways of reshaping questions so that old puzzles look like part of a larger, maybe cleaner picture. Some of these ideas come from asking deep symmetry questions that physicists have long studied. Symmetry is a calm, useful idea. If laws of nature remain the same under certain flips, like swapping left and right, or swapping particles with antiparticles, then that suggests a kind of balance. But in nature, some symmetries are only slightly broken, and those small breaks can have big effects. For example, certain tiny breaks in symmetry and particle behavior are the reason matter won over antimatter here. Mirror models explore whether those breaks might be paired by opposite breaks elsewhere. Imagine a small folded paper boat floating on a pond. On one side of the fold, the boat floats toward the left. On the other side, a similar boat floats toward the right. Each boat has its own little world. From a distance, they form a balance pair. That image captures the gentleness of mirror ideas, two halves making a whole. There are also other, quieter versions of mirror thinking. Some suggest that the laws of physics might be the same, but acting in opposite directions in a twin cosmos. Others imagine that what looks like a mirror is actually a hidden layer that only shows itself through subtle effects. For instance, if a mirror region is separated from ours by a great distance or by a kind of barrier, we might never meet its particles directly, but its gravity could still pull at us slightly, or rare events could leave faint marks on the oldest light. Scientists consider such possibilities with care, looking for soft signs rather than loud proclamations. A small, gentle story may help the feeling of this idea. Once, two musicians sat on opposite sides of a thin wall. One played a slow tune forward, the other, without meeting the first, found a tune that felt like it ran backward. When the wall was opened briefly, the two tunes fit together in a strange, beautiful way, like a piece and its reflection in sound. The audience felt both surprise and peace. The mirror universe suggestion is like that. Two calm halves that, if brought into view together, might make a strange but ordered whole. It is worth noting how these ideas fit with other views we have already met. A mirror region could be one bubble in a multiverse of many bubbles. It could be one cycle in a long rhythmic universe that flips its arrow from one cycle to the next, or it could be folded into a quantum origin where symmetry is natural and breakings are balanced across a larger context. Each of these pictures can be sewn together in different ways, creating a fabric of possibilities. The real work of science is to test which seams hold. Testing is the quiet art here. Scientists look for telltale signs, tiny differences in the oldest light, rare particles from afar, or odd gravitational shifts. So far, no clear direct sign of a mirror region has been found, but the search is not over. The universe is vast and our tools are still growing in power. A calm watchfulness, patient measurements, slow thinking, and careful math can move us closer to an answer. There is a final, gentle point to remember. Whether or not a mirror universe exists, the idea itself has value. It helps us widen our imagination to see that balance and asymmetry can both be parts of a larger pattern. It reminds us that what looks like an absolute fact, like the dominance of matter, may be only a local story, not the whole story. As we draw this chapter to a close, let your mind rest on the image of the mirror. See your reflection beside you, similar and different, steady and reversed. Let this image remind you of how many ways the cosmos might be arranged. In the next chapter, we will move into another wide idea, the holographic cosmos, where the universe might be like a picture projected from a deeper space. That thought may change how we think about beginnings entirely. Breathe slowly now and feel the quiet pleasure of considering a balanced whole. Two sides that hold each other. Let that balance settle as you rest. Chapter 10. The Holographic Cosmos. Take a slow breath and picture a simple hologram. A small square of film that, when lit, shows a full floating image of a flower. The flower seems to have depth, yet it lives on a thin, flat sheet. That gentle trick of light is the heart of a strange idea in modern thought. Perhaps our three-dimensional world is like that hologram, a projection of deeper facts written on a faraway surface. The phrase, holographic cosmos, asks us to hold this image softly and then stretch it until it fills the sky. Start with a calm image. Imagine a beach at sunset, where the wet sand catches the light and shows a long, flat reflection of the colours above. The reflection contains a picture of the sky, but it is not the sky itself. It is a record laid out on a surface. The holographic idea says something like this. The full story of what happens inside a region of space may be encoded in a precise way on the boundary that surrounds that region. The very information about what exists and how it behaves could be stored on that outer skin, rather than in the volume we move through. This sounds strange at first, but there are reasons that make the thought feel gentle and plausible. One hint comes from black holes. A black hole is a quiet, heavy object in space that swallows light and matter. Long ago, people noticed something odd. The amount of disorder or informational content that a black hole can hold seems to be tied not to its volume but to the area of its edge, its surface. It is as though all the stories of what fell into the black hole are written on its skin. This surprising idea tilts our sense of where information lives. If a place that gathers everything into itself stores its information on its surface, maybe more generally the universe stores its deepest facts on far edges. From that simple turn comes a gentle, wide thought. Space and even time might be emergent, growing out of simpler informational rules that live on boundaries. The inside world with its people, planets, and rivers would then be a kind of projection that follows those rules. The image of a hologram helps. A thin sheet can hold enough pattern to show a complex scene when lit the right way. In the same way, a lower dimensional description could hold the pattern that gives rise to our familiar higher dimensional world. One calm way to feel this is to imagine a theatre screen. Behind the screen there is a set of actors and ropes. In front of it, a light projects shapes that form a picture. The actors and ropes are the deep code. The picture on the screen is the world we walk through. Both viewpoints are valid. One explains the other. If this is so, then the question of before the Big Bang may be reframed. Instead of asking what came before the projection, we might ask about the state of the code on the surface. The beginning could be a change in the deeper pattern, rather than a moment inside the projected scene. That change of viewpoint eases some problems and opens others. If space and time are not fundamental but come from information, then the singularities and puzzles we met earlier could be smoothed out when seen from the code. The place where equations blow up might be a place where the projection method changes its rule, but the underlying code remains well behaved. This is a comforting picture. What looked like a hard limit from the inside is a gentle feature from the outside. There is a small, soothing story to hold this idea. Long ago, a potter learned how to make a delicate lamp by carving patterns on a thin shell. When light shone through, the lamp cast a complex scene on the walls, trees, birds, and hills, all emerging from marks on the shell. A child asked, "Where did the hills come from?" The potter answered, "From the pattern on the shell and the light. The hills do not live apart from that. They depend on how we light and read the shell." The holographic thought is like that. The reality we walk in may come from rules and patterns that, when read by the right light, become the three-dimensional world. How might this idea change our view of the beginning? If the deepest data are on a surface, the start of our universe might be a simple change in that surface, a reordering of information that then projects as a new, expanding interior. Asking what was before becomes asking what happened to the boundary. That is a shift from seeking earlier moments inside time to seeking changes in the deeper code that creates time. It is a subtle but soothing reframing. Beginnings are not only events but reorganizations of information. There are also calm, practical notes. The holographic view has been made precise in certain mathematical settings and shows how a lower dimensional description can fully describe a higher dimensional world. Those successes are not a proof that our whole cosmos is a hologram, but they offer a real example where this strange idea works. That makes the thought less like fantasy and more like a promising map. It gives scientists something to test and to explore. If the universe really is encoded on an edge, then clues of that encoding might be detectable in tiny patterns or relations we've not yet fully read. The idea also touches the nature of reality and meaning in a gentle way. If space and time emerge from information, then information itself becomes central. The way bits and relations are arranged is what gives things their being. In such a view, the universe is not only made of stuff, it is made of structure. That thought moves us softly from substance to pattern, from bricks to code. It resonates with many human arts. A melody is not the wood of the instrument, but the pattern of notes that forms it. A painting is not only pigment, but the arrangement that the eye reads. The holographic idea invites us to see the cosmos as a grand pattern that makes worlds when it is read. It is important to hold limits with care. Even if the holographic idea is true in some sense, it does not mean our lives are less real, or that the world is an illusion in a careless way. The projection we experience is richly real. The fact that a scene can be encoded on a surface does not shrink its meaning. A projected sunset can still move the heart. The alteration is in how we trace origins, not in diminishing value. As you listen, imagine again the thin sheet of a hologram or the carved shell of the potter's lamp. Picture how much depth and story can spring from a small, well-ordered surface. Let this image ease the pressure of looking for a single, first moment inside time. The first moment might be a shift in the deeper pattern that creates time and space. That shift can be gentle or sharp, but either way it reframes the nature of beginnings. In the next chapter, we will explore an idea that also rethinks nothing. What nothingness might actually mean and whether true nothing can exist. We will then move into questions where consciousness and the cosmos meet. For now, breathe slowly and feel the quieting power of a new viewpoint. Sometimes solving a puzzle simply means choosing a better map. Chapter 11. The Landscape of Nothingness. Take a slow breath and imagine a wide, empty field just after dawn. The air is cool, there is no house, no tree, not even a single stone. It feels empty, calm, and still. Now hold that image for a moment. When people say nothing, they often mean a field like this, a place with no stuff in it. But when scientists and philosophers talk carefully, they discover that nothing can have many faces. Tonight, we'll walk across that field and gently name the shapes that hide inside the idea of nothing. First, let us notice a soft fact. Empty does not always mean simple. In our everyday life, an empty box is easy to picture. But in physics, even empty space can have a kind of life. The quiet field may seem still, but under the grass there may be roots, worms, and small pipes. In the same way, the vacuum of space, what we call empty space, can have properties. It has a kind of energy, and it can support fields that ripple and wiggle. These tiny movements are usually so small we do not feel them, but they are real. So when we say nothing, we must first ask, which nothing do we mean? One kind of nothing is the quantum vacuum. Imagine a calm pond at night. From the surface to our eye, it seems still. But if you listen carefully, you'll hear faint sounds. Insects, a soft breeze, the tiny plip of a falling drop. The quantum vacuum is like that pond. It is not simply blank. It hums with small, quick fluctuations. These fluctuations can create brief pairs of particles that appear and then vanish. Most of the time, they leave no lasting trace. But in some cases, like in the early universe or near very strong gravity, these tiny events can have larger effects. So the quantum vacuum is not absolute nothing. It is a quiet kind of something that holds potential. A second face of nothing is the idea of absence of physical law. Think about a story told without grammar. No verbs, no time words, no rules for changing scenes. Would that story even be understandable? If the universe came into being out of a realm where there were no physical laws, no forces, no fields, no constants, then before the universe could be a place where the very rules that make change possible did not exist. That is a hard idea to hold, because our minds are built to think with rules. But some thinkers ask whether a kind of meta-nothing could exist, where laws are not yet written. It is a deep, quiet thought. Maybe what came before was not the absence of objects, but the absence of the rules that could make objects behave. A third sense of nothing is the idea of potential. Imagine a seed in a dark box. You might call the box empty because you cannot see the seed's future, but inside the seed is potential for a tree. In some views, nothingness is like a state of potential energy, ready to become something when conditions are right. In that sense, nothing is not a dead void, but a calm store of possibility. That is the gentle heart of many quantum origin stories. The deepest nothing is a kind of fertile quiet. One more face of nothing we ought to name is absolute nothing, a total absence of being, law, and potential. It is a pure void beyond all description. Many philosophers have argued that absolute nothing is not a stable idea. If there were truly nothing, there would be no reasons for anything to remain nothing. Anything that could exist would have some chance to appear. In simpler words, total emptiness may be impossible because even the idea of nothing seems likely to turn into a something. This is a subtle claim, and it is not proven, but it is a calm idea that appears again and again in thoughtful work. Nothing may not be a tidy basement from which we light a match. It may itself be an unstable place, prone to change. To make this feel more human, let me tell a small story. Once, a farmer had a fallow field. For a time he left it empty, thinking nothing good would come of it. But after a while, wind brought seeds, rain softened the soil, and the field sprouted. The farmer realized the field had always held the possibility of growth. Its emptiness was not final. In a like way, many scientists now think of the deep nothing as a kind of quiet field filled with the seeds of possible worlds. There is a calm logic behind why absolute nothing might be unstable. If we describe the rules of nature as giving probabilities for different outcomes, then a state with no structure at all may not be an absorbing state. It may be that the laws that describe probability make creation more natural than permanence. In such a picture, the birth of a universe could be a likely event, not a miraculous one. That thought is soothing to some because it removes the need for a separate cause outside nature. The rules inside nature could be enough to let something appear. We should also be gentle about the limits of our words. When we say before, we use time as a yardstick. But as we have met earlier, time itself might be a quality that appears along with the universe. If time does not exist in some versions of nothing, then before is a word that may not fit. The landscape of nothingness can include regions where not only matter, but time and space are also missing. It is a strange place to imagine, and the only way to do so kindly is to use metaphors and soft images, because literal pictures fail. Another calm point is that people often look to nothingness to answer deep emotional questions. Why is there something rather than nothing? Is there a purpose? Is life special? Science, however, tends to treat these as separate forms of question. Science asks how something could arise given certain rules. It can show possible paths. What those paths mean for meaning and purpose is a different conversation, one that sits in the heart and in culture. We will meet that heart later in this journey when we talk about consciousness and the human longing for origins. For now, notice that clearing the technical fog around nothing helps free us to ask deeper questions with cleaner tools. There is also room here for humility. When we probe the idea of nothing, we reveal the limits of language and of our most trusted concepts. That is not a failure, it is an opening. Some of the best work in human thought is the patient renaming of ideas so they fit better with reality. If nothing is too blunt a word, then learning its many faces helps us think better. The field we started with may be empty in one sense, but full in another. This is a quiet, freeing realization. Before moving on, let me give a small, gentle anchor to connect this chapter to what comes next. We have walked across fields of nothing and found quiet life hidden there. The next chapter will touch a subject that brings the human mind into the picture: consciousness and the cosmic question. We will ask why we care about origins and whether awareness itself might play a more central role than we usually suppose. If you have felt a small stir of wonder while listening tonight, that is part of why this next step will feel right. It ties the large, distant questions back to the small world of inner life. As you breathe now, picture the empty field again. Notice its textures, the way the grass bends, the small stones that show themselves only when the light changes. Remember that the word nothing can hold many things: the hum of a quiet vacuum, the absence of law, a store of potential, and the idea that absolute nothing may itself be unstable. Hold these without urgency. They are not answers but ways of seeing. They make the map larger and softer. When you're ready, rest into the calm of that field and let the thought of potential and quiet keep you company. In the next chapter, we will gently move inward, from fields and stars to the question of mind, why consciousness wanders at the start of things. We will explore whether the act of knowing is itself part of the story the universe tells. Chapter 12: Consciousness and the Cosmic Question. Take a slow, deep breath and let your shoulders soften. Imagine a warm room with a window that looks out at a vast quiet night. Inside that room sits a single lamp, its light small but steady. That lamp is like awareness, a tiny light that makes the world appear as more than shapes and sounds. Tonight we will move gently from the large, distant questions about the start of the universe into the close, warm question of why we care about those beginnings at all. We will ask whether consciousness is simply a late, accidental product of matter, or whether awareness might be woven into the fabric of the world itself. Why does the question of origins trouble and thrill us so much? Part of the answer is simple. We are the kinds of beings who remember and imagine. We hold events in mind and project what might happen next. Being able to ask, "Where did this come from?" is a property of minds like ours. Many other animals do not ask such abstract questions. Our curiosity grows from memory, language, and imagination, the tools that let us paint a long picture of past and future. In quiet terms, the question of origins is both an intellectual quest and a kind of self-portrait. When we ask it, we are tracing the contours of the mind that asks. One gentle view is that consciousness emerged slowly as complex matter organized itself in new ways. In this story, life arose, brains became more complex, and with certain patterns of wiring and exchange, awareness emerged. It is like a storm forming over warm seas. Individual drops are not storms, but when they join in certain ways, a new, larger pattern appears. This emergent view is humble and neat. It says that awareness depends on conditions, on matter arranged in specific, intricate patterns. If true, it means that consciousness is rare and precious, a high-order gift that the right kind of universe can produce. There is another soft and more radical view called panpsychism. The word sounds big, but the idea is simple. Perhaps basic parts of reality carry tiny, primitive forms of experience. Not a full human mind, but a small, proto-awareness that when combined in the right structures, becomes rich, reflective consciousness like ours. Picture grains of sand that each hold a glimmer. When the glimmer gathers in a glass, the glass becomes radiant. Panpsychism asks us to imagine that mind is not sprung only at the top of a long ladder, but is present in seed form in many places. If that were so, then the universe would be, in some quiet sense, always a little awake. Both views are calm ways of thinking. One puts mind as an emergent wonder. The other spreads the possibility of mind more widely. Each has strengths and puzzles. The emergent view explains why consciousness is linked to complex organization. The panpsychist view addresses a hard question called the hard problem. Why should physical stuff ever feel like anything at all? If basic entities already carry tiny feelings, that gap shrinks. But panpsychism also asks how many small feelings join into one larger unified mind. It is a subtle thing to imagine, and people continue to think about it with care. A quieter path between these views is to treat consciousness as relational. Maybe awareness is not a thing inside a brain, but a way relations among things are organized. Imagine a circle of friends around a campfire. The conversation, warmth, and shared attention create a presence that none of the friends alone fully contains. In this way, mind is a pattern of interaction. It is not only in one brain but appears when the right relations form. This view brings the social and the cosmic together. It suggests that mind might arise whenever certain kinds of systems interact in ways that support stable, self-referential patterns. How might any of this relate to the cosmic question? One gentle possibility is that the universe becomes aware through beings like us. Our self-reflection, our science, and our art could be the way the cosmos learns about itself. The phrase, "the universe knowing itself," is a poetic image. We, as small pockets of mind, are the way a vast blind process turns inward and observes. This thought is not meant to be mystical in a loose way. It is a reminder that awareness brings a new kind of reality into being, the reality of meaning, story, and value. Another bolder possibility is that consciousness is more central to reality than we usually suppose. If awareness is fundamental, the cosmic story changes its tone. Origins become not just physical events, but also shifts in the ground of experience. In such a picture, the first stirrings of the universe might be linked with the first stirrings of proto-experience. That idea can feel strange, but approached calmly, it offers a new way to knit together mind and cosmos. Whatever view we hold, there are gentle lessons. First, our curiosity about origins is not only a search for facts, it is an expression of how we are built to care. That humbles the answers. The question reflects both the world and the kind of creature we are. Second, whether consciousness is rare or widespread, it brings fresh value into the cosmos. It turns cold facts into stories, allows us to ask why, and lets beauty matter. Third, our minds offer tools, math, language, art, that help us approach these deep questions, even if we never get final answers. The act of asking and listening is itself a kind of meaningful practice. Let me tell a small, gentle story. There was a gardener who loved night. Each evening she would walk the rows and name the plants aloud, not out of habit but to attend. One night, a traveller asked why she spoke to the plants. She smiled and said, "Because naming is a way to know." When I name, the garden answers back. In the naming, I learn to be part of it. In much the same way, when minds name the stars and write equations for birth and time, the universe is invited into a kind of mutual knowing. The act does not make truths out of thin air, but it makes human meaning in a quiet, real way. There are also ethical whispers here. If awareness matters, then the way we live and care for other minds, human and non-human, gains cosmic weight. We become stewards of the ways awareness can flourish. That thought is not heavy-handed. It is a calm reminder that curiosity carries responsibility. As we move on, keep this gentle link in mind between outer and inner questions. In the next chapter, we'll step back through time again to meet ancient visions of creation that saw cycles, dreams, and endless beginnings, long before modern science put equations on paper. You may be surprised by how much those old stories echo the modern pictures we've explored. Breathe slowly now, sensing the lamp of awareness inside the room. Let the light be soft. Know that your attention is part of the very thing we are studying, a small, precious way the universe reflects on itself. Chapter 13. Ancient Visions of Creation. Without beginning. Take a slow breath and let your body soften. Imagine a long hall lit by low lamps. On the walls are painted stories that people have told for a very long time. Each picture is a way to hold wonder, a way that a whole culture learned to speak about the sky, the earth, and the deep time beyond memory. Tonight we will walk that hall slowly and listen to several of those old stories. We will not judge them by modern rules. We will hear them for their calm wisdom and their strange, gentle echoes of ideas we have met earlier. Begin with a warm, rolling image from South Asia. In many ancient Indian stories, time moves in vast cycles called kalpas. A kalpa can be a day of the gods, a span so long that our whole idea of a lifetime is like a blink. The world is born, lives, and dissolves into sleep. Later, it wakes and is born again. Within these great cycles are smaller rhythms, ages that rise and fall like tides. In some telling, creation is not a single event but a repeated happening, a slow breathing of being. That image of breath is easy to hold. The universe inhales in form, exhales into formlessness, and the pattern continues. The cycles do not feel cold, they feel like a large pledge of continuity, a way to accept endings as part of a larger flow. Moving gently to another old wisdom, Buddhist thought, often pictures existence as a wheel of becoming. The wheel turns through birth, aging, death, and rebirth. The aim in many Buddhist paths is to step off the wheel, to find a place of calm beyond the repeated turning. Even so, the wheel itself gives a deep lesson. What we call beginnings and endings are parts of a repeated rhythm. The Buddhist view is not trying to map physical cosmology in the modern sense. It is teaching a method for living and seeing. But in that method, there is a patience with cycles and a recognition that what looks like a first moment may be a point on a long, ongoing path. Turn now to Taoist images from the Far East. The Tao Te Ching and other old Tao texts speak of a source that is nameless and yet gives rise to named things. The source is not a single event, it is a flowing process, a quiet root from which rivers of form arise. Some Taoist poets describe the world as arising like mist from the earth, slowly, without sharp boundaries. The Tao invites us to see origin as an ongoing unfolding rather than a violent sudden start. That soft view has a kinship with some modern ideas that treat beginnings as smooth changes in the rules rather than a single instant of creation. Across the world, we find other ancient visions that echo similar tones. The Near East spoke of cosmic waters and a world shaped on a calm sea. Some stories imagine the first world as an egg, a round seed that opens into sky and earth. The image of the cosmic egg is powerful because it holds both unity and potential. Everything is enclosed, waiting, and then the shell opens and form emerges. This is a shape that also appears in far older and farther places, a quiet symbol of secret life becoming visible. What is striking when we hear these stories side by side is not that they give the same facts, but that they share attitudes. Many ancient cultures imagined that beginnings were not a single, sharp point, but a pattern, often cyclical, often soft, often folded into the life of gods, spirits, or deep principles. Those patterns were ways to live with the idea of time and change. They were maps for how to act, how to remember, and how to find quiet in the face of big questions. There is a gentle lesson here for modern listeners. Some of the ideas we call new, cycles, many worlds, time without a single start, have close cousins in old stories. That does not mean the ancients had equations or data. It means their imaginations reached toward similar places. They noticed patterns in life. Seasons repeat, generations return, stars die, and are reborn as new suns. In watching these patterns, they formed metaphors that later minds could meet again with different language. Let us hold a small, simple story to make this feel lived. Once in a village, people baked bread in a great communal oven. Each week the oven was built up, used, and then left to cool. A child asked, "Which was the first loaf?" The elder smiled and said, "The oven has fed many mouths." A first loaf is a way to remember, not the whole life of the fire. This little tale helps us feel how ancient traditions used beginnings for memory and meaning, rather than for strict history. Another soft point connects old thought to modern wonder. Where ancient writers used myth and symbol, modern thinkers use math and experiment. Still, both efforts are ways to make the strange less fearful and more known. Ancient cycles can be read as metaphors that prepare the mind to accept the possibility of a universe without a single, unrepeatable start. They offer courage, an emotional map for living in a cosmos that may stretch beyond our neatest labels. We should also name the human heart that made these stories. Long before telescopes and thermometers, people looked at birth, death, storms and harvests and learned to speak about cycles. Those old images carried care. Rituals that eased fear, songs that sweetened grief, and practices that asked people to live kindly in time. That emotional content still matters. It reminds us that cosmology is not only for scientists, it is for humans who sleep, dream, and tell stories by lamplight. As you listen now, allow these old images to rest in you like lanterns in a row. Let the cycle of Kalpas, the wheel of becoming, the nameless Tao, and the cosmic egg be soft companions to the modern ideas we've been exploring. Each offers a way to feel origins differently, less like a cold fact to pin down and more like a pattern to live within. Before we move on, I want to leave a quiet promise that will tug gently at your curiosity. In the chapters ahead, we will draw these threads together, science, myth, and mind, so that the final reflections will not only explain but also hold your feelings about reading the sky. We will return to questions of meaning, and we will consider how living with mystery might be the most humane choice. Breathe slowly now. Picture the painted hall and the lamps along the walls. Let the old stories and the new ideas sit together quietly. Feel how the past and the present can join in a soft conversation that keeps company with your questions. Chapter 14. The Universe. Outside of time. Take a slow breath and feel the air move in and out of your lungs. For most of us, life is a string of moments, a memory of breakfast, a plan for tomorrow, a song that started and then stopped. We live inside time, but tonight, with calm steps, we'll walk to the edge of that string and imagine a place where time does not flow at all. A place where before and after are not the right words. This is a soft, strange idea, and we'll treat it gently, with clear pictures and kind patience. First, try a simple picture. Think of a long photo strip from an old camera. Each frame on the strip is a moment. A face, a tree, a shadow. Now imagine laying all those frames side by side on a table. From the table view, every frame exists together. There is no movement on the table itself. Movement appears only when you run your finger across the frames or play them in order. In that sense, a universe outside of time is like the whole strip laid out at once. All moments are there together, and the flow we feel comes from the way a mind moves across them. This idea is sometimes called a block view of reality. It says the past, present, and future are all equally real, like different parts of a landscape. Your life is a path that goes through that landscape. From inside the path, time feels like a river. From outside, the whole river is visible at once. The strange part is that nothing about the outside view needs to happen. It simply is. That can be calm to imagine. No hurry, no fear of running out of time because every moment already exists in the great layout. Another way to meet the idea is to think of a painting. A painter can make a whole story on a single canvas. The painting can show a sunrise and also a distant afternoon, and both are present together. When you stand close, you might focus on one detail. When you step back, you see the whole scene. The painting does not move, but it holds time inside its lines. The universe outside of time is like that painting. It holds story and change without itself changing. These pictures help us hold the idea, but they also raise questions. If all times exist together, how do we explain cause and effect? The feeling that one thing leads to another? One calm reply is that cause and effect are patterns inside the whole layout. They are relationships between different parts of the landscape. Think of falling dominoes arranged in a line. The whole arrangement is fixed on the table, but we can still point to the domino that is lower and the one that is higher. The pattern of falling is there, even if nothing is moving on the table. This way, causes are like links in a map, not signals that travel through empty space. Another deep question touches free will. If the whole timeline already exists, do our choices matter? This can feel heavy, but we can meet it simply. Even if the map is laid out, the part of the map that corresponds to you still contains choices and experiences. Whether the map was made all at once or built step by step, the value of kindness, love, and effort is not erased. The point may shift from whether things are fixed to how we live inside them. Our feelings, our acts of care, and our attention still matter. They shape the texture of the moments and the way the story is read by those who live it. There are other ways to think of outside time views. Some scientists imagine that time is a local feature like the weather. In some places the weather is calm, in others storms rage. Time might behave differently in different parts of the greater reality. Our experience of a steady flow could be a local weather pattern inside the larger calm. This helps soften the sharpness of the idea. Instead of a single, hard truth about time, we might have many gentle ways it appears. A small story can help this sink in. Once, a traveller found a row of doors, each opening into a room painted in a different style. In one room, clocks ticked slowly and sunlight moved as if on a stage. In another room, no clock worked at all. Shadows didn't seem to change. The traveller learned that inside each room the rules were different, and that stepping from one room to another changed how events felt. The rooms did not argue, they simply were. This story holds the calm possibility that time can be a local rule that varies with place. We should also notice the limits of our language. Words like before and after are tools shaped for life inside time. When we move outside that life, words strain. That is okay. The mind often needs images, stories, and careful metaphors to think about what it cannot feel directly. Painting, music, and soft stories are better companions here than harsh definitions. Give yourself permission to sit with the image of the laid-out photo strip without demanding a full explanation. There is also a quiet link between this idea and the way some modern thinkers describe the deep laws of nature. If the world at its deepest level is described by patterns or equations that do not have time built into them, then time might emerge when those patterns are read in a certain way. Like seeing a movie when its frames are arranged in order, the flow appears when the right structure is present. From this view, outside time existence is not strange. It is simply the deeper landscape from which our felt time grows. What does this mean for the big question? What was before the Big Bang? If time as we feel it did not exist before the event we call the Big Bang, then before might not be the right word. Instead, the Big Bang might be a feature inside the laid-out map, a place where conditions change in a way that looks like a beginning from inside, but which is just one part of the larger landscape. That is a gentle way to hold the idea without sharp paradox. Beginnings can be local features in a greater timeless whole. Let us end this chapter with a quiet image. Picture a long train of lanterns stretching across a dark field. If you walk beside them, the world moves with your steps. If you climb up a hill and look down, all the lanterns shine together, each in its place. Both views are true. Inside the landscape there is movement and living. Outside there is calm and completeness. Both views can hold meaning. Both can teach us to be small and steady and full of shame-free wonder. In the next chapter we will fold our ideas back toward the human heart. We will consider how our search for beginnings connects us to awe and belonging, and how that search shapes the way we live. For now, let the image of the photo strip rest in your mind. Breathe in slowly and out slowly. Feel how relief can come from letting some questions be wide and some answers be small. Chapter 15. The Human Connection to the Infinite. Take a slow, deep breath and let your shoulders drop. Imagine standing on a hill at night with the air cool against your face. Below, the lights of town scatter like soft fireflies. Above, the stars make a wide, slow pattern. In that quiet, you might feel very small and strangely wide at the same time. That warm, mixed feeling is part of what it means to be human in a vast universe. Tonight we will sit with that feeling and explore how the question of origins reaches into our lives, how it shapes art, faith, fear, comfort, and the small ways we find meaning. Begin by noticing a simple thing. The question of where we came from is not just a scientific puzzle, it is a personal pull. When people ask about beginnings, they are often asking about place and belonging. Who am I inside all of this? Where do I fit? These are not questions science cannot touch. They are questions many ways of knowing try to answer. Science offers facts and models. Story, ritual, and art offer mood and meaning. Both can sit together like two hands holding a single cup. There's a quiet courage in looking up. For many, the sky invites stories that make the inner life calmer. Think of a traveller lighting a small fire under a wide, empty sky. The traveller may not solve cosmic equations that night, but by telling a story or singing a soft song, they make that big darkness feel like a friend. In every culture, people have found rituals and images that turn awe into a steady place to stand. They name stars, mark seasons, and gather around shared stories. Those acts are not lesser than scientific work. They're another way of tending the human need to belong. Art responds to the infinite in gentle, honest ways. Painters, poets, musicians, and filmmakers take the cold facts of space and weave them into scenes that touch the heart. A simple line of poetry can make a distant galaxy feel near. A slow piece of music can turn our rush of thought into a calm procession. Art gives us places to practice wonder. It trains the muscles we need to hold big questions without panic. When you listen to a soft voice read a quiet story about the stars, your chest may open a little. That small opening matters. It is where curiosity meets comfort. Faith and myth also reach into this same space. For some people, the story of the universe is told in sacred texts and rituals that give life shape. Those stories often answer not only how things began, but why they matter. They offer practices that help people live with the unknown. Prayer, meditation, song, and shared meals. Even for people who do not hold religious beliefs, the rhythms of ritual can steady the heart. Lighting a candle, saying thanks before a meal, or simply watching the moonrise can be small rituals that turn the infinite into an intimate practice. There's also a gentle honesty about fear. The unknown can make people anxious. When we face the vastness and the idea that some questions may have no clear answer, we sometimes feel very small in an uncomfortable way. That is normal. The wise approach is not to hide from the fear, but to learn to sit with it like a quiet guest. Breathing, naming feelings, and reaching out to others are small tools that help. Remember that wonder and fear often travel together. The same sky that makes you tremble can also make you feel alive. Our search for origins also shapes how we live in very practical ways. Learning that the planet is a fragile place orbiting an ordinary star has led many to care more for the Earth. Knowing that life depends on rare and delicate factors can make us more careful stewards of what we have. The cosmic view can produce humility, a softening of pride, and a stronger sense of responsibility. If life is rare and precious, then kindness and care become virtues with cosmic meaning. This is not a heavy claim. It is a quiet nudge toward living with attention. There is a social side, too. We grow together when we talk about beginnings. Families share stories about where they come from. Cultures pass down myths, and friends sit up late and trade ideas. These conversations weave a net of belonging. Even in the modern age, where many answers come from data and equations, the simple act of speaking about the stars with another person keeps us human. It says, "We do not face the sky alone. We face it together." Let me tell a small story that holds this close. Once, in a small town, a child found an old map in a drawer. The map showed a coastline that had changed over time and had small notes written in the margins by grandparents and great-grandparents. The child sat out in the yard at night and traced the map with a finger. As she read the notes, she felt a gentle lift, a sense that she was part of a line of people who had watched the same sea. The map did not answer the ultimate cosmic question, but it made the child feel less alone. It connected her to family and place, and that connection made the sky above her feel softer, richer, and more like home. There is also a creative way the human mind meets the infinite, through play and thought experiments. Scientists use careful games of imagination to test how the universe may have begun. Writers weave tales that make those games feel human. This mix of play and thought keeps inquiry alive and light. It helps us stay curious without becoming driven by a hunger that must be satisfied at all costs. Curiosity that rests in humility is a wonderful thing. Another gentle truth is that mystery itself can be meaningful. We tend to think meaning comes only from answers, yet sometimes letting a question remain open deepens it. Mystery can be a kind of quiet companion that invites curiosity and care. Think of an old church bell. Its echo fades slowly, and in that fade the listener finds time to breathe. A question can echo the same way and give the mind room to think slowly, to grow patient. We should also give ourselves credit for the work we do to understand. Science, art, and ritual are long labours of care. Each small act, a careful observation, a song sung before sleep, a quiet talk with a friend, stitches together a larger habit of attention. That habit is how cultures survive and how individuals find steadiness in the wide sky. Before we move on, it is worth naming how these human connections tie back to the technical ideas we have explored. Whether the universe began in a quantum fluctuation, a bounce, or a rounded no-boundary state, the human response is similar. We feel awe, we tell stories, we make art, and we act with care. The scientific maps guide our understanding, and the human maps guide how we live with what we know. Neither is complete without the other. Together they make a small, living wisdom. As you listen now, place your hand over your heart for a slow moment. Feel the steady thrum there. Let it remind you that even in the vastness, your small, steady life matters. Let the thought of your breath connect you to the larger rhythms. Your life is both a brief flicker and part of a long unfolding. That double sense can be a source of quiet strength. In the next chapter, we will step toward the close of this long journey by speaking about the mystery that remains, how accepting not knowing can itself be beautiful. We will also reflect on how to live with questions that have no easy answer. For now, rest in the sense that the human heart is part of the story. Our care and curiosity give the cosmos a kind of gentle meaning. Chapter 16. The Mystery That Remains. Take a slow breath and feel it fill your belly. Let your shoulders drop. Tonight we've walked far and softly, through ideas and images that stretch from the smallest flicker to the widest sky. Now we come to a gentle place, the mystery that remains. This is not a place of failure. It's a place of calm truth. Some questions do not close into tidy answers, and that is part of what makes them precious. Let us sit with that idea for a while. First, notice how many good maps we now have. We have careful stories about the hot early universe. We have ideas that let the deep past be read in light and in motion. We have bold thoughts, bubbles, cycles, mirrors, and holograms that widen our view. We also have honest limits, places where our sharpest tools go soft and say, "We do not know yet." That mixture is not messy. It is a healthy sign that our thinking is alive. A map that shows unknown regions is more honest than one that pretends to cover everything. There is a calm beauty in not knowing. Picture a long road that vanishes into fog. The parts you can see are clear and real. The fog hides the rest. You could stamp your foot and demand new light, or you could walk slowly toward the mist and feel how it cools your face. Both moves are human. Science is the patient walking toward the mist. Art and story sit on the road and help you notice the way the mist smells and moves. Both ways matter. Both are honest ways of living with mystery. Another gentle thought is that mystery invites many paths. When a question is open, many minds can explore it with different tools. A physicist writes equations. A poet writes a line. A painter paints colour across the sky. A quiet listener breathes and thinks of home. Each path is a way to touch the unknown. When we gather these responses together, the mystery becomes louder and kinder. It becomes a place where knowledge and feeling meet. There is also a practical softness to hold. Not all mysteries are the same. Some are gaps we can close with better data and clearer thinking. For these, patient work, better instruments, and careful teams will help. Other mysteries may be deep in the way our language or minds are built. These may require new tools of thought, new metaphors, or even new ways of sensing. Both kinds of mystery deserve respect. The first kind calls for slow, steady work. The second kind calls for imagination and humility. We can also notice how mystery affects our mood. Some people find comfort in endings and clear answers. Others find a fierce pleasure in the open question. If the unknown makes you anxious, that is real and worth attention. Gentle practices, deep breaths, soft music, sharing thoughts with a friend help the heart settle. If the unknown delights you, then curiosity is your warm companion. Either way, mystery can be met kindly. It is useful, too, to remember the story of progress. There have been many times when the world hid a secret and we slowly found the key. Each new key only widened the next set of locked doors. That is not a failure. It is the nature of deep learning. The universe is rich in detail, and as we learn, we find ever more layers. This pattern tells us to be patient and steady. Long turns of thought and slow experiments have often led to surprises. There is another gentle truth. Sometimes the question is as important as the answer. When we ask what existed before, we tune a part of our minds that cares for history, cause, and meaning. That tuning does not vanish if a final answer is not found. The questions shape how we live. They make us kinder, more careful, and more humble. They teach us to sit with not knowing without giving up our hunger for truth. Let me give a small story to hold this kindly. Long ago, a village tended an old tall tree. People came to the tree to ask questions and to rest. One day a child asked whether the tree had always been there. An elder answered, "No, but it has been part of our life for as long as our songs remember it. Some parts of its life are clear, some parts are lost. That is okay." The tree teaches us to care for what we can. The tree did not solve the child's curiosity, but it offered a way to live with it. That is the fine art we practice with the universe. There is also the chance that mystery itself is a teacher. When we accept not knowing, we might find our questions become kinder and more curious. We stop trying to grab final answers and start learning to live within wonder. That shift can change how we treat others, how we approach art, and how we decide to act in the world. Accepting mystery does not mean giving up on truth. It means choosing a steadier pace. As you listen, you might feel a mix of wanting and letting go. That is natural. If a quiet pull to know remains, tuck it gently into your chest as a warm ember. Let it be a guide for patient learning rather than a burning need that steals your rest. If a sense of ease has come, Breathe into it and let it soften the small edges of the day. Before we move on, I want to remind you that the journey continues. In the chapters ahead, we will weave together what we have seen, science, story, and the human heart, so the ending of this documentary feels like a soft place to rest. There are more gentle images to share, more small stories, and a final reflection that will close the whole night in a calm way. If you have stayed with me this far, thank you. Your presence is part of the story. If you feel moved, quietly tap the like button, and only if this voice fits with you, subscribe so we may meet again for other calm journeys. Tell me in the comments where you're listening from and what time it is. It is a small, lovely way to remember that other hearts are awake at the same hour. Now breathe slowly, feeling the quiet acceptances grow in your chest. Let the idea of mystery be a gentle blanket, not a cold wall. We will keep walking together slowly and kindly toward the rest of the night,